For non-porous surfaces, we're going to be looking at two chemical reactions that take place specifically with your the amino acids in your secretions. Your ridge skin does not have oily secretions like we talked about yesterday in class, but they do have aqueous secretions, soluble secretions that contain a number of salts, sodium chloride being one, as well as amino acids and proteins. Proteins contain amino acids, and if you don't put gloves on when you do this exercise today, you're going to end up with purple hands, and it will last about a week. We had one student yesterday who made us touch her nose like this, and so she had a nice purple streak coming down here, and she was going to try to tell everyone that someone punched her and it was a bruise. But she looked really nice. I'm sure that you could probably go like this and become an Indian, or do all kinds of wonderful things that you want to do and have fun with the colors. But we're going to learn how to use those, ninhydrin, and as well as a fluorescent ninhydrin amino acid chemical, which we call DFO. There's another one called 1,2-indane-dione, which we can also use, but the process is exactly the same as for using DFO. Now, over time, the original amino acid developing reagent was ninhydrin, and it was developed in 1915. And since then has been used for fingerprint work. The Secret Service, because they do a lot of document work, and they've been wanting to get more and more and better prints off of paper kinds of documents. So there's been a lot of research from them in this regard. One of the things that they developed was fluorescent ways of looking for fingerprints using fluorescent indicators. Fluorescent indicators are inherently more sensitive than indicators that do not have fluorescent capabilities. So DFO is one of those, but you never want to use DFO after you do ninhydrin. There's a cascade that you can use, and if you look on that latent print sequencing chart back there, sequential processing chart back there, you get an indication of the different kinds of reagents you can use for different kinds of surfaces. But generally, for porous surfaces, paper and cardboard, the first thing you're going to do is you do some sort of a visual examination. You're probably not going to see anything, or you might, but you can shine a laser on it. You might see some, or an alternate light source, you might see some inherent fluorescence. But bottom line is you're going to start doing a sequence of things. One of the things that you can do is to fume it with iodine. It's a very old technique. It's not very sensitive, but it's typically been used in those situations where you have very sensitive documents, historical documents, that you can't afford to treat chemically. Because the reason you can use iodine is that iodine will become incorporated into the fatty materials of your fingerprint residue and just get stuck in there for a while, but eventually it's going to leach out and go away. The next step would be to use a chemical like DFO, or 1,2-indane-dione. And there are people who think that indane-dione and DFO are interchangeable. There's some that think that indane-dione is more sensitive. There's some who think that DFO is more sensitive. There's a whole bunch of chemical formulations for making these reagents, and the most recent formulation for indane-dione is to put zinc in the solution, and people think that works better. The British just did a study and they found it to be just as sensitive, or DFO to be just as sensitive. The difference between the two is that the DFO reaction is slower than the indane-dione reaction, but we're going to use sufficient enough heat to make it go pretty quickly. So we're going to be doing a cascade of first DFO and then ninhydrin. You can't do the reverse. Geez, I've even got some on me already. I didn't even pick anything up yet today. Right, there's a purple color, and that's not the right finger to do that with, I know, but that's a purple color. So we're going to be doing DFO and ninhydrin, and we're going to be looking at a couple of different porous surfaces to look at fingerprints on them. You can use your own fingerprints just to make sure you have them, and we'll go through that process. All right, so the DFO reagent was made up yesterday, so it's fairly fresh. And what we're going to do is pour a small amount into the tray. Now normally you want to keep the DFO reagent in a dark container like this, but since we use it up very quickly in class, I don't have to worry about it. And we're going to impregnate the paper with the reagent. We're going to let it dry for a second or two. Now there's a lot of vinegar in here. It smells like a vinaigrette. And we'll dip it once again. Always cap it back up again. Now, you want to heat this up. Now you want to use heat without any humidity when we do this. Okay. All right, let's put goggles on and see what the progress is. See prints? There's also a lot of other stuff on there. Some prints. Okay, so that's one way of doing it. Another way to do it with the same is to go over to the trusty system we have over here, which is known as an iron. This is the way we used to do it. I have this very handy little grill that I use for hamburgers and when we have parties. Actually, you'd never want to eat a hamburger off of this. We use an iron. Oops, that's the wrong iron. You use an iron that's marked dry, and this generally doesn't work very well, but it does work a little bit. Not nearly as well as that. And what you do is we turn this on to warm. Maybe a little higher than that. And then this baby comes on and it gets real hot. And you just keep going over. You're about 1/8 of an inch to 1/4 of an inch above paper. When you get into thicker materials like cardboard, this doesn't work as well, but for small pieces of paper like this, it works okay. But even a blue-green wavelength, you see how now it looks black instead of purple? Now you're getting more contrast. And so you should be able to see the fingerprints better. And if you're going to be taking photographs of these, you might want to take a photograph, if you're looking up on a light background like this, at 515, that's the fourth of them, 515. But at 515 nanometers, with just clear goggles or with glasses or something like that, you have a better contrast than you do if it's go back to the regular one. Even if I put a white light on this. .535 works, but you get more background, you see. 515 works, you get darker.